very interesting talk. Now I would like to invite our next speaker, Dr. Yossi Oren, Assistant Professor in the Department of Software and System Engineering in Gurion University.
While everybody's settling down, I found a discount key on the floor. Does this belong to anybody? You know what, why don't I check whose this is? I'll just put it inside this computer. No? Okay, so, yalla. Oh, I can't do it this way. אני צריך פרזנטר. מה שבא לי. עד שאני... You want to start? You ready? הגזמתי, אני לא מאמין איזה גרסה זה של PowerPoint. So, hi. Hi everybody, I'm Yossi. This is my website. You can find out what we're doing in Gurion, implementation security. And I want to talk to you about IoT attacks through the supply chain. So, let's assume you're a purchasing manager and you want to decide which kind of IoT device you're going to buy for your air conditioner, for your, I don't know, pressure sensor, whatever. So you're obviously going to look at things such as the quality of the software, the quality of the cloud, let's face it, the price. You're not going to look at the hardware. Frankly, the hardware doesn't interest anybody. It's just a cost for the manufacturer. If your sensor is going to be stuck in the ceiling somewhere, you don't really care about the hardware. What this means is that a company that can optimize on its hardware can be more competitive and be more profitable and actually win in the end in this very, very fiercely competitive market called IoT. So how do we optimize our costs? And did actually all the letters disappear from my presentation? No, okay, no. So there is something called international supply chain or global supply chain. And when you use the supply chain optimally, you don't have to manage your inventory of components for whatever you're building. You just send out a wish on this global supply chain. I want this memory device, I want this capacitor, I want this antenna, and all the vendors in the world compete for your offer on the best price and best quality, and then you can build your device. And the advantages of this this method are amazing because you don't have any inventory of devices. You have a very, very low overhead, very low waste. You're very agile, and so basically, companies can win by having a better supply chain. So this is lovely. This is very nice. But exposing yourself this way has its flaws, has risk for the company. And this isn't actually relevant to cyber. When you're opening your company to the global supply chain, you are going to get additional risks. And the main risk is that all sorts of low-quality devices are traveling through this global supply chain, and it's very, very difficult to track them. And what do I mean low-quality devices? They're sometimes called counterfeit devices, even though it's not completely accurate. These are devices which are mainly three categories. One of these devices are what are called remarked devices. So you have a device which is supposed to be used for, let's say, gaming, but you're marketing it for servers, and suddenly it can't stand the duty cycle. Another thing is called recycling. You buy old devices, and even though you think that electronics doesn't get old, electronic devices do get old, ICs do get old, so old devices sold as new is a problem. And the third thing is something called upbinning, and upbinning means that when a manufacturer tests a chip outside of the factory, it tries it at various clock speeds, and the fastest clock speed at which it's reliable, this is what's called the speed bin. And there are variations in the manufacturing process. Sometimes you get slower devices and faster devices from the same manufacturing run. So upbinning means that I buy a slow processor and I change it, I counterfeit it so it looks like it's a faster processor. Most of the time you won't notice until, for example, it's in a rocket and the rocket falls or something like that. So these are risks that everybody has, in this supply chain economy, but they're not really relevant to me. I'm not a business guy, I'm an electrical engineering guy. So what I'm talking about now is mainly cyber attacks. So I'm going to talk about cyber attacks using supply chain devices, and I'm going to do it using an IoT. So what's special about IoT devices? First of all, I want to focus. I'm going to attack the end user. So the name of the game is, I am an adversary, and I am able to insert myself into the supply chain, the flow of components, to somebody who's building an IoT device, and I want to attack somebody who's going to buy these IoT devices and install them. Okay? So what is special about IoT devices is they interact with the environment. So IoT devices have sensors. So one attack I can do on my adversary is just collect the data from these sensors, which is basically spying, okay? Plain old spying. Instead of using a microphone, I'm going to use an IoT device. Another thing I can do is corrupt these sensor readings. So maybe I can use this to hide an emergency. I can cause some kind of business process to go wrong. I can break into the business. All sorts of very creative and imaginary things you can do if you control the sensor outputs. Another thing that IoT devices have are actuators. Actuators are things which actually affect the physical world. So if you have an IoT device which is in control of a pump, of a door, of a gate, of anything of that source, if I can control that, obviously I can do some damage. And the third thing, which is actually what Michal talked about, this casino break, I can pivot into the network. So if I can control the IoT device, I can jump from this IoT device into other devices on the network, maybe more interesting targets, what's called lateral movement. Maybe I can jump from this sprinkler or from this aquarium into the server. So I want to make an offensive IoT attack through the supply chain. So there are three main things I need to take care of. The first thing is I need to design my implant. I need to create something which will fit into the supply chain. And I need to target this device. I need to get it to my victim. And I need to communicate with it. I need to give it, controls or read whatever readings are coming out of it. So now let's go over these things one after the other. So the first thing is designing the implant. So what you have here on the left is the common house fly. Size is 5 to 7 millimeters. And what you have on the right is actually a commercial flash chip using the USON 8, the ultra small 8-pin package. The size is 2 by 3 millimeters. So this is the size of an SPI flash, ultra small SPI flash. What I'm going to suggest as a design for a malicious implant is a little memory device like this. I will place it between the memory storing the program for my IoT device, whatever it is, and the CPU which is going to read out this program, and I'm going to do what is called a man-in-the-middle attack. Instead of loading whatever operating software the IoT device was supposed to load, it will load my software. So this is very cheap, very hard to detect, and I will be able to do whatever I want as long as I can't modify the hardware. I'll have to use whatever hardware is inside the device. So you probably heard of this very, very fiercely contested story by Bloomberg about the super micro hack. Did the Chinese government insert or did it not insert an implant into the super micro motherboards? So assuming it did, I don't know if it did, but assuming they did, this is what they were supposed to have done. So they took a little small SPI flash and put it in the man in the middle. Okay, next thing is targeting the implant. I need to get this implant to my victim. And I don't have any innovation here. What I would do if I were an attacker is just create 8,000, 10,000, 100,000 of these malicious implants and cast them upon the water. And hopefully, one of them will hit my target. And in the Snowden revelations, there are stories about the NSA intercepting a pallet, like a package of thousands of routers which were supposed to be shipped to a Middle Eastern country, and adding a backdoor to each one of them. So this means that I will be able to hit my victim. Also, other people will also get hit, but I don't care because I'm a black hat. And now the third thing I actually want to focus on a little more is how do I communicate with the implant. So I can't modify the hardware of the implant. I can only modify the software. So I'll have to use whatever I have in the implant. For example, I can't communicate over Wi-Fi with an implant that doesn't have a Wi-Fi chip. It only has this low-power Zigbee chip or something like that. So this is a bit of research that my student Oren did with some collaborators. You can go to the website here. And what we did is we built a way for a very, very low-cost RF transmitter transmitting on the same frequency band as Wi-Fi, for example, a smart light bulb or a sprinkler and so on, to communicate with a Wi-Fi device which doesn't run any malicious software. And the technique we designed is called micro-jamming. So what you see here is the time axis. And what you see here, the red dotted line, is the data the implant is trying to send out. And the blue, what you see actually in blue, are the delays in just fetching random images from the internet and measuring the time it took to get them over JavaScript. So you see that when we're applying this microjamming, very, very small disturbance in the frequency range, you get a slightly higher delay in the time for these images to come back. And you can read more about this in the paper. So I can communicate with the device using the hardware I have. We have other works on that. You can also go to the website and find out. So I built an implant, great. How do you defend yourself against a malicious IoT implant attack which is going through the supply chain? So there are various things you can do. And you have to defend yourself in various ways. So the first thing you might like to do is what's called supply chain pedigree. So now you're buying any old junk of the supply chain. Maybe you should be more careful about that. And there are two general schools of thought. How do you protect yourself against counterfeit devices or bad devices going in the supply chain? One of them is called, you need to kind of authenticate the chip itself. So maybe you add some kind of DNA or microprinting or some kind of expensive microprinting to the device. So now with a microscope you can identify it. This is something that DARPA has the budget to do. I doubt that you'll be in your next smart air conditioner. The second thing you can do is you protect your pedigree, what is called in transit. Every time the device is sold or purchased, you have this public register, maybe on the blockchain, I don't care, where this device is traveling. And if you know the device came from a safe factory and ended up in your device, then you're safe. The problem is that a supply chain can include something like 15 steps between the manufacturer and the end user. Another thing you can do is what's called internal firewalls. So we are in the Checkpoint building where firewalls are very well known. But let's think about putting a firewall inside our device. So this is research by my student Omer Schwartz. You can read about it here. And if you see figure 54, we actually put a very, very cheap device called, we called it an inline firewall. And this device analyzes the data going between the various chips on this device, in this case a smartphone. And frankly, things like pressure sensors, light sensors have very, very simple behaviors if they're not under attack. So we are able to train a machine learning model on these things and very, very easily detect when they're behaving out of order and kind of respond to that. The third thing I can do is what's called Byzantine resistant systems. And this is just, this is one line of defense. I'm going to assume that there are going to be bad components in my device. And now I need to think, how can I protect myself? So I'm moving the circle of trust closer to the CPU. And now I'm trying to think, is the sensor reading I'm getting accurate? Is it under attack? And again, there is another work, I don't have a link here. How do I apply machine learning to the outputs of a sensor to determine if this is a sensor, if it's reading what it's supposed to read or something else? And the last thing I can do is, this is actually, this is a trend of the future. I can stop buying things from the supply chain and start 3D printing everything in-house. So this is not something we can do right now. We don't have the capability to print integrated circuits outside very expensive fabs. But this is something that I think will be more and more prevalent in the future trends because you can't actually trust the supply chain. This is what I believe. So in summary, the international supply chain is very, very complicated, and This means that attackers will get their devices inside, and they will hit the victims, and they'll also hit all sorts of other parties. This is a factor we can't go around with. And you need to talk about multi-layer defense to protect against this. And in closing words, before I thank you, I want to give you a little quote by the US Director of National Intelligence, which says that IoT devices are going to be used for surveillance, monitoring, and targeting, and to gain access to networks or user credentials. So you can be inspired or frightened by this quote. And with that,